Hey everyone, welcome to my YouTube channel called Base 12 Crazy. This is my first video with my new YouTube channel, and I decided just to change it from my old YouTube channel because I realized that the old YouTube channel called Duodecimal Division, there's not a lot of people Googling duodecimal division. I don't know how many people are going to be Googling Base 12 Crazy, but it's got more excitement to me. I feel like I'm more happy being crazy than just representing duodecimal division. I mean, that's still what it's all about, Base 12. This is a math YouTube channel. It's a YouTube channel about math, but Base 12 math. So right away, Base 12 sounds kind of crazy when you start talking about it. You go, yeah, 6 times 6 is 30 in duodecimal. 5 times 5 is 21. And it's like, that sounds crazy, right? Exactly. So that's part of it. Sounds a little bit crazy when you're doing the math in Base 12. But even more than that, it's also because when I tell people, hey, guess what? I figured out a better way, a more precise way, more accurate. I think precise is the right word though. Precise, a more precise version of pi when you do it in Base 12. And then they look at me and they kind of like, they just go, that's crazy. Or ask somebody who's got like a math PhD. I say, hey, tell me, in the math world, you know, you've been in there, what do you think? If someone says they got a more accurate version, a more precise version of pi, what are they going to think? And he said, well, honest opinion, they're going to think that you're crazy. He said batshit crazy, but still, just, you know, crazy. I get it. You're probably thinking, oh, yeah, this guy, he's crazy. He thinks he's got a better version of pi. That's like the most famous number. I got my math book here, just illustrated history of numbers and everything. Pi comes in at the 14th chapter. The ratio of the circumference of a circle to its diameter is called pi. That's the name of the Greek letter pi, which is used as the number symbol. With good reason, pi has been called the most famous number in the world. Most famous number in the world. And I'm saying I got a better version, more precise. It's close. It's close in decimal 10, or the decimal version, or base 10. It's the closest you're going to get in base 10. I mean, I'm not saying everybody's wrong. I'm just saying that base 12 is better. And it's not about converting one number to the other number, because that's just the same number. It's a little bit different. It's a little bit more precise. So what I'm going to do in my upcoming videos is I'm going to show you the geometric pattern. And that's the thing too. Whenever you hear about pi, sure, it's the circumference divided by the diameter. Got it. Nice, simple, straightforward, very, you know, basic in a way. But then, so you have that circle, but then you just convert, where is it? You don't see it. The example in Wikipedia is a wheel that rolls, and you sort of see that the circumference kind of stretched out. And then it says 3.141, and then it goes on, but it doesn't really show you the division in process. It doesn't say where the diameter, how it fits 3 times around, where those gaps are. That's the thing, there's no gaps, and there is gaps. There's gaps in pi. There's spaces. That's why it goes on forever, is because there's an empty space that's always almost filled up, but it's not. That's why it can go on and on and on. There's always a gap. There's always a space in that circle. And the way that they show it is that the example is just like one long piece of string or something that goes around a wheel, and then there's a little gap at the end that keeps getting smaller and smaller and smaller as you keep adding, but you never quite get, and you're adding 0.5 and 0.2 and 0.1 and 0.8 and 0.9, and then 9.985. This goes on and on and on. You're always adding more, but there's this little empty hole space into infinity. It sounds weird, and everyone's like, wow, it's so crazy. I got it. It's crazy, right? Pi is a kind of a crazy number. So I'm gonna show you. I'm gonna show you geometrically, so that the gap is in the circumference. It's in the circle. It's in the middle of the circle that stretches out to the sides. Pi has to fit into the microcosm. It has to. It's everywhere. It's in the clouds. It's in the movement of the waves. It's everywhere in the physical universe. That's another thing we're going to talk about, is this dimensionless points. What's up with that? There are okay, I got it. You know, you want to be really, you know, precise. but you need some kind of space around those dimensionless points just to say that they have a dimension and that there's a distance from one to another. You can't even imagine really a dimensionless point. It has to be in relationship to something. And as soon as it's in relationship to something, it's got a dimension, it's got a distance. It's just there's a little bit, I don't want to start any big arguments here, but I'm just saying it doesn't quite make sense. Lines made up of dimensionless points. Not in applied math. So this is applied math YouTube channel. Okay, so applied math, we're talking about the physical universe. Everything in the physical universe has an inside and an outside, or a front and a back, and a middle. Everything. You know, the orbit of the moon and through the space, it's got like, there's an apogee and a perigee or whatever. There's an outside and an inside. Everything, even the little electromagnetic pulse, has some kind of space around it. You know, some part where the energy is going one way and the energy is going the other way, and things are moving, and there's, and like I say, outside, inside, every orbit of anything, every rotating disk, every flying, moving, stationary, everything is got some kind of space around it, and that's where pi is. And that space, pi is like the empty space somehow. So there's a conspiracy against circles. I'm going to expose this conspiracy. Right? Crazy. Why would there be a conspiracy against circles? Why is there a conspiracy against numbers? Again, welcome to my YouTube channel, Base 12 Crazy. I'm going to be telling you all the crazy stuff that's out there. And I know no one's even going to be watching this. By the time you get to this, it's like going to be years past. That's another thing I realized after posting my YouTube duodecimal division. Nobody's rushing to see these videos. They're just sitting there like, that's who's going to watch it, right? So that's fine. So, yeah, okay, so I want to tell you what it is. So I'm going to just read out pi, because guess what? My pi repeats. It's a decimal that repeats after 100 or so. Again, I always never know, what do I tell you? The decimal, the base 12 pi has 96 digits, 96 points, but 96 isn't 96 in decimal. It's bigger than that. It's 9 times 12 plus 6. 9 times 12 is like 90, 108 plus 6 is 114 digits. 96 base 12 numbers. So I'm just going to read it out. You know, it's a square root. Again, square root. Why? What's the big deal about pi being a square root? It makes sense if it's, you know, circles are mostly square roots. I mean, for this video, you need this YouTube channel. You're going to need to know at least like the Pythagorean theorem. It's kind of grade 8 math around there. If you know the basics of that, it's not complicated. It's only sounds complicated because it's going to be base 12. Okay, I'm going to stick to that base 12. I'm going to be introducing you to two other numerals that you never even heard of, or maybe you have. You know, if you're here looking for base 12, maybe you already know that. Great. I'm going to explain to you why they look like that, why all the numerals look like they do. You know, and there's going to be controversy around that because it doesn't. There's things that just don't make sense, and I'm going to show you, and you're going to think, wow, that's crazy. So this is good, right? Base 12 Crazy. Welcome to my YouTube channel. Here we go. Pi. Okay, this equation, it's just going to be like the square root of, say, 148 divided by 18.08. So you can get out your base 12 calculator, you know, and just do that. And the first few digits you're going to see are 9, right? Square root of 9 is 3. So we're on the right track. And at 9 point B. Okay, so like that's the right away, 9 point B. What's up with that? Well, B is like 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, 10. I'm going to start with A and B just to get you a feel, but like I say, they're going to have numerals that represent those numbers, different names, everything. That's coming up in future videos. I'm going to be posting at least one video a week, probably more, but at least that. So you can, you know, if you want to subscribe and do all that stuff, do it. This is going to be interesting. It's going to be like crazy. We're going to go like from Egypt to other places, snow, ice, jazz, all kinds. I've had dreams. Like Noah, right? Noah, everybody thought Noah was crazy, but look what happened, right? So the ark, I'm building an ark here. 9.B8017191. Right? Lots of Lots of ones. It's very precise at the beginning there. B801. Like, so you're like just, you're close already. 9 point B8017191841567. 46794109211. 68B. There's a B again. 84B. Lots of B's. We haven't had any A's yet, but lots of all those B's. So yeah, B84B 052288 6149 05B 973 4355 9980 B20 3B A 4 A 2 A 3 7A. So there's all those A's all of a sudden, right? 654, kind of interesting. 754 27 AB 29 AA 5303 70 B 69933 5A 72 B 60248 78 66223 B 09 B 801. Now we're repeating. So I don't know if I read that so great or so well, but that was it right there. You just heard the what's going to become the more famous Pi version, the real thing, the more precise. And I'm going to show you in future video, not too many, because I want to get this out there right away, how that works. Like how does that look on a geometric design in a graph paper. I'm going to be using graph paper, right? Just super simple. I mean, you can't tell it's graph paper. I can see it doesn't look like that. We're going to be using graph paper. We're going to be using just basics, super simple stuff. So that's about it, really. I'm going to keep all these videos under 15 minutes, which is good. We're already at 12. So that's fine. You're going to be happy to hear that. And then probably a lot of them are going to be even shorter because it doesn't take that long to explain things. I just want short little snippets. So I'm going to be sharing with you the dreams that I had that kind of helped me pull this all together, because otherwise I wouldn't have got it. I'm not that smart, actually, to be honest. I don't have a degree in math. You know, that's why I'm doing this, because if I had a degree in math, then I wouldn't even bother doing this. I already know that I'm wrong. Right? So all you math people who are watching this, you're thinking, I already know this guy's wrong. I don't even know why I'm paying attention to this video. But my friend told me I should, so okay, thanks. So thank you. If you're watching this and you're still watching, thank you. Okay, I appreciate that. And I promise I'm going to make this as entertaining as I can and interesting. So Base 12 Crazy, thanks for watching. I'm gonna take you to places you never thought it's okay. I'm just gonna show you. I'm sharing with you what I got, and it's been I've been making videos out here for the past year, and I realize it's just a little bit crazy. I got that, so that's okay. It's okay to be crazy, and I think I said enough. That's it. So thank you for watching, and stay tuned. So next video I'm going to show you that geometric pattern as best I can, and like I say, I'm also going to be sharing with you why numerals look the way they do, what the degrees. It's kind of like ancient knowledge in a little bit. Why the degrees, how that works. You know, that's something nobody really knows where that came from. Base 12. Someone a long time ago was using base 12, and we've forgotten. They designed our numerals. They designed, that's where our 360 degrees comes from, except in duodecimal or base 12, it's not 360 degrees, it's 260 degrees, right? 2 times 144, 6 times 12, add those together, you get 360. So 260 degrees. I just share with you pretty intense information. It sounds crazy, right? So welcome to Base 12 Crazy. Thanks for watching. Don't forget to subscribe. It's going to be great. See you next week. Bye for now.